In Atomic, when you find that two EHRs were created for the same patient, the same person, you can request to merge both EHRs. Yeah. Here you can just enter the ID of one EHR, the ID of the other EHR after you checked that. You enter a reason why you want to merge those EHRs. Maybe it's because you detected that the patient is the same and you should explain what you did so someone can come in and review your request and authorize your request. I will show you how to authorize a request. So here we have a list of historical merges. So here we list all the merges that were done, the merges that were denied, and the merges that are pending. Yeah, the ones that were done means that those were authorized. Yeah, so I have here the last request that I did a couple of minutes ago. I can, if I'm the reviewer, I can click here, review, and I can see the secondary EHR and some information about the secondary EHR, the subject associated with that EHR, some information about internal, compositions and contributions, and the primary. So this means that the secondary will be merged into the primary. That is that after the merge, the canonical EHR ID will be the primary one. Yeah, so the secondary will still work. So if you do a query, yeah, by this EHR will still work, but internally it will resolve to the primary one. Yeah, and future references should use the primary ID. Yeah. So here we can review information about the EHRs. We can enter an authorization note. This can be for approving or for rejecting. Yeah. And here, if the EHRs, and in general we have patients associated with the EHRs, if the EHRs have a patient associated with them, here we compare some fields that are part of the demographic repository. So that is the person that is actually the patient associated with the primary or the secondary. So in the secondary, we see that we have the name Paolo Pasos, and we have a date of birth. This is fake information. And we have the sex. This is the sex value. This means male, yeah, internally. But the primary, instead of Paolo, has Pablo, yeah, and all the rest of the information is the same. So this is the information that is in the secondary, this is the information that is in the primary. And you can see here the similarity between these sets of values. So it's comparing this with this, this with this, this with this, yeah, using different matching operators, yeah. In this case, for instance, the names are compared using the Levenstein comparison. So it's a distance based on the Levenstein function. That means how many characters you need to change to actually convert one string into another. So basically, it allows you to match strings that have typos in them, like different letters, or if you transpose characters when you're writing, it will detect that. So it doesn't detect that this is different than this. It detects that this is 80% similar to this. Yeah. The same with the last name, but the last name is exactly the same, so it considers 100% match. The same with the date of birth, because for the date of birth, you can mistype, for instance, one of the parts, or you might have a partial date. So you might know that the person on the secondary was born in February this year, and you don't know the date, the exact day. Yeah. On the other one, we could have the day. So instead of saying that this part is different than this, the whole date, we say that this is some percentage similar to this, for instance. Yeah, and that gives you some a higher score for the similarity. And this is the total score. So if the both patients match more than 90%, it is safe to say, okay, they are very similar. It looks like they are the same person. Yeah. If it's less than that, we will show you kind of a confirm. Are you sure you want to really merge these two EHRs, because the patient information doesn't look too similar? Yeah. And the reviewer could still authorize the merge. Yeah. If it's less than, for instance, 70%, it might be a mismatch, or maybe the comparison configuration is off and might need some adjustments. Yeah, and all of this comparison is actually configurable, so it's dynamically configurable depending on the template that was used to store the demographic information. In other words, when you store a person that will be the patient of an EHR, you actually store the person based on an OpenEHR archetype and template. And depending on the structure of that template, you will have a different matching algorithm. Yeah, and that matching algorithm can be configured in the system. Yeah, so I can authorize or reject. If I authorize, basically this ID will be mapped to this ID, and when we do queries by this ID or this ID, either ID, both will resolve to the primary. Yeah. And this has internal controls, like if you merge this 144 into this other EHR and then you create another request to merge 144 into another EHR, it will say this can't be merged because it's already the secondary of this. So you can't merge the same EHR into two different EHRs. You must respect the tree structure. Yeah, but you could merge this, because it's the primary, into another primary, so it becomes the secondary of another primary. It's a basic way of merging stuff. And since the merge in this case is a logical merge, it's pretty easy really to unmerge. So in case you authorize something but it was a mistake, really, because the request had maybe errors, the authorization, maybe the authorizer, the reviewer didn't see the errors, and the person actually authorized the merge, we can unmerge without much problems. Yeah, so because we are not moving data, we are just changing different IDs and references internally, that all of that can be undone. Yeah, so there is no problem on that. So this is very important to verify that the person is actually the same, so actually matches with a good matching value, yeah, more than some percent. This could vary between different clinics and hospitals, and we can adjust everything, yeah, because everything is configurable. So for instance, here we have a configuration, for instance here, and this is actually the configuration of that comparison that I just showed you. So we basically can create a configuration that says, okay, let's compare from this template. This is a template ID, so these are people that are patients, yeah, and the ones that comply with this template, because you can have different templates for different kinds of patients too. This specific template will be compared using, for instance, in this case, this is in Spanish, so this is first name, last name or surname, date of birth and sex, and this is the archetype where all this information is defined, And these are the specific archetype paths to each data point: first name, last name, date of birth, sex. You can add more of these, and you can say, okay, for instance, the first name will be compared using the Levenstein similarity, what I mentioned before. The last name, the same. The date of birth, the same. And the sex, because it is a code, it will be an exact match. Yeah. So those are the small, point-to-point comparisons. And the full score will be given by the result of each individual comparison times a weight, and the weight should sum 1, because 1 means 100%. Yeah. In this case, we have first name and last name with Levenstein similarity. It's basically 70% of the identity match. Yeah, we give a 20% to the date of birth and just 10% for the sex, because you have the biological sex. You may basically have 2 possibilities. Yeah, we can have also 3, 4, depending on the region and the data, how data is considered correct. We can also say kind of unknown or other types of sex. Yeah, but the weight, because there are no many possibilities. Let's say you have top 10 possibilities for the sex. Yeah, it's just 10%. Yeah. You can also, if in your country or region it's normal to use, for instance, a second last name or the mother's last name, like we do in South America. Yeah, you can also add that to the algorithm and maybe assign a different weight, but all the weights should sum 100%. And that is actually very easy to create. I have other tests here for different also templates. So we can come here, and for creating such a comparison, you should pick the template, you pick the archetype, you see all the data in the archetype. For instance, we have here IDs, kind of ID cards, nationality, sex, date of birth. Yeah, so we can pick, for instance, I will show you how this is created. Date of birth, here's the name of that node, here's the archetype, is this one, here's the path to this node in the archetype, and the comparison algorithm will be, for date of birth, we will use Levenstein. Yeah, and we can add this item to our comparison, and I can give this item a weight here. Yeah, let's say 20. Let's create the same comparison. First name, archetype path, and this will be Levenstein similarity. And let's give this 35, and this is how you create a comparison. So it's the same. I create another for the last name, 35, another for the sex will be 10, and this will be 100%, the total weight, and this will show green. For instance, if I do 80% here, this will be green, so I can save this configuration for the comparison. So basically, when you want to merge 2 EHRs that the patients are defined by this specific template, then this comparison algorithm, I would say, or index or function will be applied on that EHR merge review window that you saw before. Yeah, so this is very dynamic. You can adjust this for different templates that you use, and this can be as complex as you want. You can compare as many fields as you want, just to be sure that both patients are the same, both identities are the same. Yeah, so this HR merge has 2 big, I would say, parts. One is the definition of the comparison for the patient identity, and the other is the process for requesting, reviewing, authorizing, or rejecting. Yeah, and the third, I would say, that is really after the merge is the query, because after you have the merge of two EHRs, when you query and you filter by one of those EHR IDs, you will retrieve information from really both EHRs. Yeah. So internally, the information is not moved anywhere. It's just sitting there under their old EHR IDs. We just map everything to one single canonical EHR ID. Yeah, so physically we don't move data. Yeah, and that's a simple way of implementing a fairly, secure way of merging EHRs. If you have any questions, just let me know. If you want me to execute the full flow on requesting, merging, authorizing, rejecting, etc., just let me know. But I wanted to show you how this works in general. Thank you.